Welcome or welcome back to 3 Inquisitive Kids. This is the problem of the week for January 1st, which is the first week of 2024. Over here, I forgot to write 2024. If the perimeter of a particular square is 2024 inches, what is the area of the square in square inches? Express your answer as a decimal to the nearest hundredth. So we have our square. Its perimeter is 2024, and each side is equal. So when we divide 2024 by 4, we get 56. So it's 56 for each of these sides. Then what is the area of the square? Well, we just have to multiply length times width, which is 56 times 56. So you can go ahead and multiply. So we get 3,136. And so that's our answer to the first problem. Remember to add the units. For the second problem, what is the median of the first 2024 positive integers? Express your answer as a decimal to the nearest tenth. So we first have to draw out a diagram. The first integer is 1. The last positive integer is 2024. Let's first divide 2024 in half, which becomes 1012, and test this number out. In this case, all the numbers before 1012, not including 1012, is 1011 numbers. The numbers that come after 1012, and because we know that the median has to be right in the middle between 1 and 2024, we know that 1012 is not right because it's not the same distance to either side. So now let's try 1012.5. We get an extra 0.5 in the distance to the left and a minus 0.5 of the distance on the right. So now 1012 on the right, the distance, becomes 1011.5. Now you can see that the distances are equal. So the median of the first 2024 positive integers is 1012 and a half. Now on to the third problem. In the arithmetic sequence, -7, -4, -1, and so on, what is the first term that's going to be greater than 2024? So as you can see, we are jumping by threes. Add 3 and add 3. So we don't have to deal with negative numbers. We can first jump to the first positive number, which is 2. So let's say that this entire sequence started from 2. 2 plus a certain number of terms minus 1 times the value that's being added on every single time. In this case, it's 3, is equal to a number that's greater than 2024. Let's say that it's 2025. We wrote 2025 down because it's the smallest term that could be greater than 2024. And if you're wondering how we got this equation, you can go look at the arithmetic sequences playlist that we have on our channel. Basically, I'll give you a little overview. You start from the very first term, which we indicated was going to be 2. And n is the certain number of terms you are dealing with. We don't know that yet, so that's why we substituted in a variable. And then up here, this times 3 is how many 3s you're adding to the first term. And we wrote a minus 1 over here because when you're talking about how many 3s are added to the first term, you are not including the first term itself. So you have to subtract 1 term. And now we can go solve for n. 3n minus 3 equals 2023. 3n is equal to 2026. And this is not going to divide well, but we still have to go ahead and try, which is 2026. Divided by 3, 6, we get 18, bring down a 2, 7. So our answer becomes 675 with a remainder of 1. And because this number is counting how many terms there are, we can't have any remainders. So because we have a remainder, we have to round up, which gives us 676. So now we can go back to this equation and substitute n for 676. So then 2 plus 675 times 3 gives us a certain number. That's what we're calculating for. This equals 2 plus 2025, which is 2027. So the first term of this arithmetic sequence that's going to be greater than 2024 is 2027. Now here's our last problem. If it is noon right now, what time will it be in 2024 hours? Be sure to indicate AM or PM. It's better to use the military clock time. So the military clock time goes all the way up to 24. So after you pass noon, which is 12 o'clock, it becomes 13 o'clock, 14 o'clock, and so on until 24 o'clock. So if it's noon right now, then right now it's 12 o'clock. Every day is 24 hours, right? So after every single 24 hours, it's going to go back to the same time it was the day before. So every full cycle is 24 hours, and we have 24 hours in total. So we can find how many full cycles of 24 are in 2024. We can put 9 over here, see if it works. 24 times 9 equals 36. You bring up 3, you get 216. But 216 is too big for 202, so now it must be 8. And 124 less than 216 would be 192. So you subtract that to get a remainder of 10. You bring down the 4. And for this, you can do 24 times 4, which is 96. So we get a remainder of 8. 8 hours. There will be 84 full cycles where the time goes back to 12 o'clock. And after these 84 cycles are all used up, we still have 8 hours left. So now we can count 8 hours from 12 o'clock, which is 20 o'clock. But remember, we still have to convert this time back into our normal daily use time. So this, it would be PM, right? And we can subtract 12 o'clock from it to get 8. So it's 8 PM.